Hey guys, welcome to your lesson on the properties of real numbers. I have a chart here that pretty much sums up all the properties that we're going to be talking about today. You can take a screenshot of it, you can copy it down if you want to pause the video now, but you certainly don't have to because we're going to go into more detail with each property in the upcoming slides. So briefly, we have the commutative property, the associative property, the distributive property, the identity property, and the inverse property. Now, probably the most popular property that we are going to be using throughout the school year is the distributive property. So hopefully you are familiar with that. If not, we're going to be doing some examples in the upcoming slides. So here we go. So the first property that we're going to talk about is the commutative property. Now, the word commutative stems from commute. And if you think about commuting somewhere, right, so if I commute to work, and I'm going to call this H for home and W for work, so I'm going to go from home to work. And at the end of the day, I'm going to go turn around and I'm going to go from work all the way back home. Now, the distance is the same. The only difference is the direction that I went. So whether I'm going from work back to home or from home to work. That's what the commutative property essentially is that you can change the order or the direction of something, but the distance, like the equivalency, remains the same. So this works in addition and multiplication, and you can change the order in adding or multiplying, and it won't change the final result. Just like when I'm driving to work, it's the same distance one way, going from my house to my job, as it is going the opposite way from my job to my house. Okay? And there's some examples there with actual numbers to help it make more sense. So the first example on the addition side is we have 3 plus 5, so that's going to give us 8 no matter what. And if we switch the order, 5 plus 3, it's still going to give me 8. So they're still equivalent. Multiplication, same thing. If you multiply 2 and 6 together, okay, you're going to get 12. If you flip the order and you multiply 6 and then 2, you're still going to get 12. So no matter how you look at it, it's going to work out. And that is the commutative property. If you need to pause the video now to write anything down, please do so. Otherwise, we're going to move on to the next property. Okay, the next property is the associative property. Now, how I think of this one is associative. If you break down that word, it sounds like associate. And if you think about who you associate with, right? What friends do you have? What groups of people do you hang out with? Okay, grouping. So, associative property, you want to think of grouping. And again, this only works in addition and multiplication. So if you look at the addition side, we've got the fact that when you add, you can group numbers in any combination. Okay? I always focus on the number example because I think it makes more sense than using the variables or the letters. So if you look at, it says 2 plus 5 plus 3 is the same thing as 2 plus 5 plus 3. So it's written in the same order, just the parentheses group things differently, and it tells you what to do first. So if we look at the left-hand side, we're going to add 5 and 3 together first, and we're going to get 8. So now we have 2 plus 8 on the left. And on the right-hand side, parentheses first, we're going to add 2 and 5 together to get 7. And then we have plus 3 over here. Now, working at the left again, we've got 2 and 8 that we add together, that gives us 10. and 7 and 3 added together will also give us 10. So these two are equivalent. It works. Moving on to the multiplication side, okay, we have 2 times 5 times 3, where the 5 and 3 are grouped together, is equal to 2 times 5 times 3, where the 2 and 5 are grouped together. Now, if you're not sure how I know to do parentheses first, then we have to backtrack a little and explain that order of operations PEMDAS, where you have P for parentheses, E for exponents, M for multiplication, D for division, A for addition, and finally S for subtraction. So PEMDAS tells me to focus on parentheses first. So I am going to multiply 5 and 3 together first and get 15. So I have 2 times 15 on the left. Now I know in these examples they use a multiplication symbol like a little X. I try to stay clear of using X's like that because we're going to use X so much as a letter X to solve, that I don't want to get us confused. So I tend to stick to parentheses to group things with multiplication. Okay, so we've got that on the left, and we need to multiply 2 and 5 together on the right because we do parentheses first. So that gives us 10, and then we also have to multiply that with 3. And we're going to end up with 2 times 15 is going to give us 30, and on the other side, 10 times 3 will also give us 30, so it works. Again, if you need to copy anything down, feel free to pause the video now to catch up. Otherwise, we're going to move on to the distributive property. Okay, so this is essentially just an example of what the distributive property will look like. Okay, I believe you've learned this last year in 8th grade, but I'm not sure. So either way, we're going to go over it. When you have a number outside of the parentheses, okay, you can take that number, so in this example, the 4, and you can multiply it to everything in the parentheses. That's why we have these little arcs here, okay, showing what's happening. So when you multiply 4 and x together, you're going to get 4x. Then when you move on and multiply 4 and positive 3 together, you get a positive 12. So your final answer is 4x plus 12. Keep in mind, you can't combine 4x and 12 because they're not like terms, so you just keep it as is. Now, we're going to try some examples with this on the next page. So this is what your homework is going to look like tonight, where you have a couple examples to do where you have to show how you distribute. So in the first example, we have a -6 on the outside of the parentheses, and so we are going to distribute that -6 to both the A and the 8. Now, when we take -6 and multiply it with A, we're going to end up with -6A. Now that there's a plus 8, so we're going to do -6 times a positive 8. That's going to give me a -48. And that's my final answer. So you can leave it like that. You can box it in. You can do whatever you want just to show that that's your final answer. -6A minus 48. Okay, number 2. On question 2, we have 4 on the outside of the parentheses. So we're going to distribute that 4 to everything inside of the parentheses. And when we do that, we're going to end up with 4 times 1, that gives us 4. 4 times a positive 9x is going to give us a positive 36x. Now 4 and 36x are not like terms, so we're going to keep that as is, and there's our final answer. Okay, number 3. We've got 6. That needs to distribute to both of these terms here. So when we multiply 6 and negative 5n together, we are going to end up with negative 30n. And when we multiply 6 times 7, we're going to end up with a positive 42. And so our final answer after we've distributed is negative 30n plus 42. Last example with the distributive property. So we have 9m plus 10 inside of the parentheses, and we have a 2 now on the outside on the other side. And that's just there to show you that it doesn't matter if the number is before the parentheses or after. It can still be distributed. It's just you don't see this written like over here so often, but that's okay. The dot there, in case you're confused, is a multiplication symbol. Some textbooks use it, some worksheets. I don't love it. I would prefer just the number next to it without a dot, but that's okay. So distribute the 2 to the 9m and the 10. So when you do that, we're going to end up with 2 times 9m is going to be 18m. 2 times a positive 10 is going to be plus 20. And we have our final answer, so I will box it in. Okay. Again, if you need to catch up and write this down, feel free to pause the video now. Otherwise, we're going to move on to a different property, and we're on to the additive identity. Okay, additive. It's a fancy word, but really it's just telling us to add. Okay? So, when we're talking about the additive identity, what we're talking about is an example where you can add something to your original number and end up with the same original number, which means that we have to add 0 onto any number and it will still give us that same initial number, right? And you know this, 5 plus 0 is still going to be 5. So our original number was 5. If we want to end up with 5 in the end, the only way to do that is to add 0. On another example, we've got 0 plus 99 equals 99. So if our original number was 99 and we want to end up with 99, again, the only way we can do that is by adding 0. So when you're talking about adding, the identity element in that scenario is always, always, always going to be 0. 0 is the only number that this will work every single time. If you add anything to 0, it won't change the original number. Okay, moving on to another type of identity, but this time it is the multiplicative identity. Now, again, multiplicative sounds like a fancy word, but really, if you break it down, it's really just telling you to multiply. Okay? So, the word multiplicative means to multiply. If we're talking about the identity again, that means we want to end up with the same number we started with. The only number that works every time when multiplying is the number 1. So, if you take any number, right, we've got a times 1 equals a. A is just representing whatever number you want. They also give you an example 3. So 3 times 1 is still going to give you 3, right? So we started with 3, we want to end with 3. The only number that allows us to do that when multiplying is multiplying with 1, okay? Same thing as the additive. Additive identity property works when you're adding 0 to any number, it doesn't change it. The multiplicative identity property works when you're multiplying with 1, because multiplying anything by 1 will not change it at all. Okay, moving on, almost done, don't worry. On to inverse operations. Okay, so additive, again, just means to add, so don't let that word freak you out. The additive inverse of a number is its mirror image, okay? So when you think about inverse, when your camera is inverted, right? You've seen this. When you can invert the view of the camera, it just flips you around, right? So think of it like a mirror. The additive inverse of -5, if you look at a number line, the opposite of that, if you were to flip that mirror, would give you +5, okay? The additive inverse of 7, let's say, would turn into -7. So the opposite is always just the negative version of whatever you're talking about, okay? If you started with a negative, like for instance, -12, the inverse of -12, the additive inverse of -12, would then be a +12, okay? And if you're not sure if this is going to work, what's going to happen is that when you add these inverse numbers together, the answer will always give you 0 when you're talking about adding, okay? That's why they're opposites, because they cancel each other out. Okay. Feel free to pause it if you need to write any of this down or take a screenshot of this page before we move on to the multiplicative inverse. Okay. So this next one says inverse property of multiplication. You might also hear the phrase multiplicative inverse, okay? It means the same thing. So multiplicative inverse, same thing as inverse property of multiplication. So you're trying to find that mirror image of a number when multiplying. And how you do this is you want to multiply two numbers together and have the end result always be equal to 1. Now you notice that 1 pops up a lot when multiplying, when we're talking about these properties. Just like 0 pops up a lot when you're talking about the additive properties. Okay, that's not a coincidence. These values of 1 and 0 are what we call identity elements. So that's why we're seeing them repeat so often. Okay, so back to an example of numbers. When you're multiplying, especially with fractions, you might see it more clearly. If you typed into your calculator, okay, or if you could do this in your head, 4/7 times 7/4 is equal to 1. And there's a couple ways to show you how that works if you don't have a calculator. So if you remember how to multiply with fractions, multiply the numerators together. So 4 times 7, 28. Multiply the denominators together. 7 times 4 is 28. Now, fractions are really just showing you a division problem, right? That fraction bar is telling you to divide. So, if you divide 28 by 28, you're going to end up with an answer of 1. On the next example, okay, they give you 2/3, multiplying that with 3/2. Again, multiply the numerators together, and you're going to end up with 6. Multiply the denominators together, and you're also going to end up with 6. And again, fractions are telling you to divide. 6 divided by 6 is 1. Now you might be thinking, how will this work if you're not talking about a fraction, right? So for instance, if I want to use my favorite number, which is 7, okay, what can I multiply 7 by to end up with an answer of 1? So, in order to figure this out, I want to turn 7 into a fraction, okay? So if I want to take 7 and make it a fraction without changing the result of 7, all I have to do is put that number over 1. Now it's a fraction. Now if you've noticed the pattern here in these fractions before, you might notice that it's just flipped upside down. So in the first example, you had 4 in the top, 7 in the bottom, and then in the next one, when you multiply it, you flipped it, so 7 was in the top and 4 was in the bottom. That's not a coincidence. That's the reason why you're able to get an answer of 1. So when you flip 7 over 1, your new fraction is going to be 1 over 7. And if you type in 7 over 1 times 1 over 7, you're going to get an answer of 1. Okay? So, inverse property of multiplication states that the product means to multiply of any number and its multiplicative inverse is always going to be 1. Okay? And when you're doing a mirror image of a fraction, it's that number flipped upside down. Okay? Again, feel free to pause the video now if you need to copy any of this down. I think we only have one more slide to get through. Last one. Okay. Zero property of multiplication. This is also known as the multiplicative property of 0. And I'm going to write that down because that phrasing is going to show up and I don't want you to be confused with what it means. So, multiplicative property of 0. Sorry that my handwriting's not that great on an iPad, but hopefully you'll be able to read it. Okay, so multiplicative property of 0 is the formal name, right? It makes it sound really fancy. But they also just call it the 0 property of multiplication. You can see how the two names are interchangeable. They're very much the same. And the title will pretty much tell you what you're doing. So 0, so we're using the number 0. And multiplication, we're obviously multiplying. And you already know that when you multiply any number with 0, you're going to end up with an answer of 0. Okay? And that's essentially it. So that sums up all the properties that we have to know. And when you get to your homework tonight, you're going to have a matching section where you look at an example and you have to match that example to the correct property name. So feel free to use this video again or look at your notes to help you with the matching portion of your homework. And that's it.